Oh, I could see only one option, sir. Request the host to record to the cloud.
Okay, let it record. I'll send you that now.
Okay, sir. Yeah.
Right. So yesterday we have seen that what are all things we are going to learn in the .NET, like C Sharp .NET, ADO, LinkU, Entity Framework, and ASP.NET. And now, what are the advantages of using this .NET framework um, to develop the applications? Here, one thing is we can develop the platform independent applications. What is meant by platform independent applications? See, normally C++ both comes under the platform dependent. Java and .NET both comes under the platform independent. See, platform is nothing but an operating system in which we are working. Platform is nothing but an operating system in which we are working. If you develop an application in one platform, and if you are able to use the same application in all the platforms, then it is said to be a platform independent. See, we are all working on the computer, but nowhere we are interacting directly with the computer. So with the computer hardware, operating system is going to interact. With the computer hardware, operating system is going to interact. So computer hardware and then operating system. And then after we will have this on top of this operating system, if you want to execute a Java application, we are supposed to install the JVM. Like if you want to execute the .NET application, we are supposed to install the .NET framework. Okay. And on top of this, we will have this Java application and .NET application. On top of the JVM, Java application will execute or installed. On top of the .NET framework, we'll install the .NET application. For example, if it is a C and C++, that program is going to interact directly with an operating system. This will be like this. So this is an operating system directly interacts with the computer hardware. C program directly interacts with the OS. C++ program directly interacts with the OS. And JVM will interact directly with the OS. .NET framework will interact directly with the OS. And Java application will interact directly with the JVM. .NET application will interact directly with the .NET framework. So now, this is computer hardware, and this is OS, operating system. And next one, this is C program. And this is, let us say, C++ program. And this is JVM, Java Virtual Machine. Like this is our .NET framework. Now, this is, let us say, Java application. And this is .NET application. Now, you see, this Java application and .NET application, as because they are not interacting directly with an operating system, they don't bother about the operating system in which it is developed and in which it is working. Only the thing is you should have installed JVM to use the Java application. Like we should have the installed .NET framework in order to install the .NET application. If you have the installed JVM, installed .NET framework, then you can make use of these applications. So C and C++, as because they are interacting directly with an operating system, these two programs are compatible with this particular operating system. We have C in Windows operating system, we have C in the Linux, we have C in the Mac. But in which operating system you are writing a program, that program can be executed only in that operating system. In other operating system, we cannot execute it, right? That is why C and C++ both comes under the platform dependent. As because they are interacting directly with the OS, they are compatible with that particular OS. Whereas when you come to the Java and .NET, as because they are not interacting directly with the OS, they are platform independent. See, based on this working principle, we can say Java and .NET both are platform independent. So initially, JVM was developed for all the platforms, like JVM for Windows, JVM for Mac, JVM for Linux, and for all the things. We have JVM for all the platforms. Initially, they developed it for all the platforms. But whereas .NET framework, initially, Microsoft people, they developed it for their own platform. So we don't have the .NET framework for other operating systems except for the Windows. So based on the working principle, we can say .NET is a platform independent as because the framework is not available for other platforms. It is a platform dependent. So initially we used to say that it is a partially platform independent. But later Microsoft people, they developed the .NET Core. So initially we have the .NET framework, then we have the .NET Core, and then we have the .NET 5, and then we have the .NET 6 and .NET 7, and then .NET 8, and then .NET 9 also they introduced beta version, right? So now initially .NET framework, different versions are there in this .NET framework. We have the 1.0 and we have the 2.0, 3.0, 3.5, 4.0, 4.5, 4.5.1, 4.5.2, and then 4.6, 4.6.1, and then 4.6.2, and then 4.7, 4.7.1, 4.7.2, and then 4.8. These are all versions available in the .NET framework. And all these versions are available for only Windows operating system. We don't have these frameworks for the other operating systems. Then after, we have the .NET Core, they developed it. So here Core 1.1, and then Core 2.1, and then Core 3.1. So these .NET Core platforms are available at this .NET Core is available for all the platforms. We have Core for the Windows, we have Core to install on Linux, we have Core to install on Mac also. So they made it purely platform independent. And after this one, they released the .NET 5. .NET 5. So in order to avoid the confusion, they named it as a Core 5 because when you say .NET 5, it can be after 4.8 or it can be after 3.1. That is why they said it as a Core 5.0. But it is a .NET 5, you can say .NET 5. They brought all the technologies under the single umbrella in this .NET 5. And after this one, we have the .NET 6, .NET 6, and then .NET 7. So from this .NET 7, .NET has become more faster than Java. .NET 7 is 3 times faster than Java in execution. And they made it very lightweight. They made it very fast also. And then now .NET 8 and even .NET 9 also. So this is how this .NET is evolved. So first .NET framework is platform dependent only. Other additions are all are platform independent. So we have for other operating systems also. So that is platform dependent and independent applications. So based on this, .NET and Java both are platform independent. Next one, we can develop the programming language independent applications. we can develop the programming language independent applications. What does it mean? See, in the .NET framework, approximately around 44 languages are there. See, Java is a single language, but .NET is a framework which contains collection of languages. Lot of things are there, like we have C sharp, we have VB, we have F sharp, we have J sharp. So different languages are there in the .NET framework. Let us assume we got one project where we divided that project into two modules. So module 1, we are giving it to team A. Module 2, we are giving it to team B. Team A, they are good in the C sharp. Team B, they are good in the VB. So team A, they can develop their module in the C sharp. Team B, they can develop their module in the VB. Later on, these two modules can be integrated into a single application. .NET framework will support for cross-language integration and cross-language inheritance. Here, there are because of two reasons. One is like CTS, that is Common Type System. In all programming languages, we will have the same data types. For example, if I define a class in the C sharp and if I try to inherit that class into the VB, if you have the same data types, then only it is possible. Otherwise, it is not possible. So in the .NET framework, every language will have same data types. What are all data types we have in the C sharp? Same data types will be there in the VB. In the same way, we have that CLS, that is common language specifications. So like all the programs will have the same specifications. Specifications like, for example, I'll tell you, integer, it occupies 4 bytes in the C sharp. Even in the VB also it occupies 4 bytes. Even in the F sharp also it occupies 4 bytes. Like all the programming languages will have the same specifications and same data types. Common type system, common language specification. So all programming languages in the C sharp will have the same data types and same specifications. Because of that, .NET framework will support for cross-language integration and cross-language inheritance. Because of that, we can develop the programming language independent applications by using the .NET framework. So that is why we can say it supports for the language interoperability. Interstate and language. Like in the same way, interoperability. Once if you define in the C sharp, let us say, if I define a class in the C sharp, say I'm writing on C sharp class, it can be used in the C sharp, it can be used in the VB, it can be used in the F sharp, it can be used in the J sharp. In all programming languages, you can make use of the C sharp class. Everywhere you can make use of that class. So it is called as language interoperability. Language interoperability. That is a programming language independent applications. Now, we are saying it as a .NET framework, what it contains generally. See, .NET framework contains two parts. One is CLR, which is Common Language Runtime. And the second one is FCL, that is called as Framework Class Library. Common Language Runtime and the Framework Class Library. See, that name itself indicates library, which contains collection of many predefined, reusable types of classes and interfaces in the form of namespaces. See, commonly used things and see, in the C, we will have the header files. C++ also will have the header files. In Java, we have the packages. In the .NET, we will have the namespaces. So what are the advantages of these things?
No need to rewrite any classes or interfaces again. We can just directly implement them by importing from different packages.
Right, right. Uh, yes. In other words, we can say, see, these are all like our folder structure and how the folder structure will be there in the system. For example, if I open D, there are a lot of folders, right? Let us assume each folder is nothing but one header file in the C, one package in the Java, one namespace in the .NET. If I open something like, if I open it, there are sub namespaces in this. If I open this one again, there are sub namespaces. If I open this one, there are classes and interfaces, and then sub namespaces. See, namespaces concept or the packages concept or these header files concept will help you to compartmentalize the names. See, in a single folder, we will not be able to have two different files with the same name, or the duplicate items we cannot have. So now what we can do, two files with the same can be there in two subfolders. So these things will help us to compartmentalize the names. So same thing, we call them as header files in the C and C++, packages in the Java, and then namespaces in the .NET. So one thing is like namespace compartmentalization. Second one is more reusability. Once if we create a namespace, it can be used in any of the, or it can be exposed to other programs and other projects also. That is the advantage. So more reusability. So this framework class library contains all namespaces. Each namespace contains sub namespaces and classes and interfaces. So framework class library contains collection of many predefined reusable types of classes and interfaces in the form of namespaces. And what about the CLR? CLR is nothing but common language runtime. Here also you can understand by seeing this, right? Common language runtime. It provides runtime environment for all .NET compliant languages. See, you can develop any kind of application, like it can be a console application, it can be a desktop application, it can be a web application. And you can make use of any language like C# or VB or F# or J#. Whatever might be the application you developed and whatever might be the language you use to develop it, that application is going to be executed inside this CLR only. Okay. This is like a common living room in your house, right? The moment when you enter, everything will be in that living area, right? So here, common language runtime, it provides just runtime environment. This is a core component of the .NET framework. Okay. And the main advantage of the CLR, it provides automatic memory management. Automatic memory management. For example, in the C program, if I want to allocate memory in the runtime, with the help of the dynamic memory allocation, we will do that. I think you might have learned that, like malloc function, cloc function, realloc, free, these functions you might have used in C for dynamic memory allocation to allocate memory from the heap area in the runtime. Allocation, see, generally, whatever the memory we have in the system, that will be under the control of operating system. So if you want to use some memory, your application should talk to this operating system and get allocate that memory, use it, and after your usage, you are supposed to give it back to an operating system so that the operating system can allocate the same for some other service. For example, by using C program, if I allocate 20 bytes of memory I used it for my program, but I did not deallocate it. I did not give it back to an operating system again. One thing is you are not using that memory. Second thing is you have not given it back to operating system. That is called memory leak. That is called memory leak because you have allocated that memory. One thing, you are not using that memory, you are not giving it back also. That we call it as memory leak. Because in C and C++, memory allocation and deallocation both are to be taken care by your program only. Programmer has to take care of allocating and deallocating the memory. But when it comes to the .NET and Java, as because your .NET application is not interacting directly with an operating system, it will not bother about the memory allocation and deallocation. So memory allocation and deallocation both will be taken care by the CLR only. So whenever there is a requirement of memory, your CLR will interact with the OS and it allocates the memory. We have allocated the memory. We have used it for our program or our application. Then after completion of your usage, you are supposed to release it right again. But here in this common language runtime, there will be a garbage collector. Even in the Java also, there is a garbage collector. There also internally it uses the same algorithm, mark and sweep algorithm. Here also mark and sweep algorithm. So this garbage collector collects all unnecessary objects then and then. And in the programming, whenever the object is no longer required, that object will be collected immediately by the garbage collector. So memory allocation and deallocation both are taken care by common language runtime CLR. That is the reason we can say CLR provides automatic memory management concept. So your application no need to worry about the allocating resources and deallocating resources. That is the main advantage of the CLR. It provides automatic memory management concept. So memory allocation and deallocation both will be taken care by the CLR. And FCL, that is a framework class library. As I said, it is a library which contains predefined classes and interfaces. So these are the two parts of the .NET framework. One is the common language runtime, another one is the framework class library. Right. How the .NET application will be compiled. See, first of all, whatever the program we write, we call it as a source code, right? And as I said, multiple languages are there in the .NET framework. And every language has got its own compiler. Every language has got its own compiler. For example, if you take C sharp, C sharp compiler, VB compiler, F sharp compiler. So every language has got its own compiler. When you write a program by using a particular language, with the help of the corresponding language compiler, we will compile the program. First source code, and then with the help of the corresponding language compiler, we will compile the program. Once if you compile the program, that will produce an assembly file. That will produce an assembly file. And this assembly file is CPU independent set of instructions. It can be used in any system. And it is not an executable code. And this assembly file contains two parts. One is MSIL, second one is metadata. MSIL, that is Microsoft Intermediate Language. That is Microsoft Intermediate Language. Second one is metadata. Metadata is nothing but data about data. We can say what are all data types we have used in our program and what are all variables we have used in our program. All that information will be there in the metadata. Other than that, every information about your application will be there in the MSIL only. So metadata contains data about your data in the application. The remaining all information in the MSIL, that is Microsoft Intermediate Language. And these two things are the parts of this assembly file. This assembly file is CPU independent set of instructions. And this is only an intermediate language. This is not an executable code. And after this one, we have one more stage of compilation, that is just-in-time compilation. Just-in-time compilation. We have different hardware architectures are available in the market. Based on the hardware architectures, .NET framework has many just-in-time compilers. We have the Etanium processors, we have the Pentium processors, we have the Neon processors, we have Xeon processors. Based on the hardware architectures available, this .NET framework has different just-in-time compilers. And these just-in-time compilers are going to convert your assembly file into corresponding CPU native code. And that CPU native code can be used only in that particular machine. We cannot use it in any another machine. Best example I'll tell you. I have a MS Office software in my pen drive, and that software can be installed in any of the system. For example, if I install that software in my system, that will work in my system. But after installation of the MS Office in my system, I cannot copy that into some other system. That is called CPU native code. But the software which I have with me is a assembly file, we can say, which can be installed in any of the system. So when you are installing this application in the system, or when you are using it for the first time, this just-in-time compilation takes place. And this just-in-time compilation converts this assembly file into or compiles into the CPU native code. And that native code can be used only in that particular system. We cannot use it in any another system. So .NET application will be compiled for two times. One is from source code to the assembly file. Second one is from assembly file to the CPU native code. So source code to assembly file we can convert with the help of the corresponding language compiler, and from assembly file to the CPU native code with the help of the just-in-time compiler. This is how the .NET application will be compiled. So two times it will be compiled, right? Next one, there are two words here. One is the managed code, example Java and .NET. Second one is the unmanaged code, which is like C and C++. So what is the difference between this managed code and unmanaged code? Managed code, which targets the runtime, is called a managed code. Uh, Simply, let us assume there are two managers. One manager is having a personal assistant and another manager is not having a personal assistant. The manager who is not having a personal assistant, everything he has to take care of things. He has to take care on his own. The manager who is having a personal assistant, so many things the personal assistant will take care. In the same way, managed code has a separate runtime environment. For example, .NET, there is a CLR. For example, if it is a Java, there is a JRE, Java runtime environment. Whereas C, C++, they don't have any separate runtime environment. They should take care of everything. Best example, memory allocation and deallocation. C, C++ programs, they are taking care of the memory allocation and deallocation. But when you come to this Java and .NET, they are not bothering about the memory allocation and deallocation. So memory allocation and deallocation both are taken care by their environment. So what are all this runtime can do? All the benefits will come to our application in the managed code. Unmanaged code, everything they should take care on their own. That is the difference. So managed code means we can say which targets the runtime is called a managed code, which doesn't targets the runtime is called a unmanaged code, right? So clear up to this one.
Yes.
Now, see, these are all basic concepts only about this .NET framework. Now, let us start how the syntaxes are going to be, and we can say the basic programming fundamentals used in programming. So first, variables and constants, and then methods and other things. So what is meant by a variable? What is meant by a variable?
It's just the name where we give to store the data in it.
Okay, very good. Very good. It's a name where we can store the data, right? It's a name given to the memory location. So simply we can say variable is nothing but memory. Variable is nothing but memory where we can store a value for use by a program. What are the values we are going to use in the programs where we store those values? That memory location is called as a variable. And variable is a quantity which we can change during program execution. So variable value can be changed in the runtime, whereas the constant value cannot be changed in the runtime. Variable and constant both are memory locations only. Variable value can be changed, but the constant value cannot be changed. And variable is a name, as you said, it is a name given to the set of memory locations. Depending upon the data type of a variable, that will occupy 2 bytes, 4 bytes, 8 bytes, or 10 bytes or something. So that's a name given to the set of memory locations. I'm typing here. Variable is nothing but memory where we can store a value for use by a program. Variable is nothing but memory where we can store a value for use by a program. And it is a quantity. It is a quantity which we can store or which we can change during the program execution. Which we can change during the program execution. Or we can say it is a name given to the set of memory locations. Set of memory locations. So that is a variable. Variable is nothing but memory. It is a quantity which we can change. It is a name given to the set of memory locations. The next one, variable naming rules. See, first thing, variable name should start with either alphabet or underscore. That means variable can have the numerals, but it should not start with the numeral. It should start with either alphabet or underscore. It should start with either alphabet or underscore. And it should not contain any special characters. It should not contain any special character except underscore. So no other special character is allowed to use in the variable names. But generally, we will not use underscore also in the .NET end. In C and C++, we use underscore. In the .NET, we can use it, but we will not use it. And next one, variable names are case sensitive. Because you know that all the programming languages are case sensitive. Capital alphabets are different from the small alphabets. And predefined keywords cannot be used as variable names. Cannot be used as variable names. Like we will have this int, float, double, for, if, continue, break, switch. All these keywords are the predefined, and these keywords cannot be used as the variable names. And syntax to declare a variable, like here, first we will specify data type, what data type it is, and then what is the variable name. And if you want to initialize it, what is that initial value you want to assign to it. Okay. And then say example, we can write that integer a. This is called variable declaration. Only declaration here it is. Unlike here, integer b equal to 100. This is variable declaration and initialization. Declaration and initialization. So this is the variable. So simply we can say variable is nothing but memory where we can store a value for use by a program. And next one, constants. What is meant by a constant? See, variable and constant both are memory locations only. Variable is also a memory location. Constant is also a memory location. But in both the memory locations, we can store the value, but the value of the constant cannot be changed. Value of the variable can be changed. So we can say it does not changes. It does not changes its value. Sorry. Its value during the program execution. It does not change its value during the program execution. And these constants are also of two different types, primary constants and the secondary constants. So primary constants, or we can call them as built-in constants. Say here integer constants. Integer constants means we can say here numbers without decimal places, or we can call them as whole numbers. Example, say here 12, 23, and then say here 45 and so on. Second one is real or float constants. Real or float constants. Example, say here 1.2, 2.3, 4.5 or 4.0, that is also float constant. We can say numbers with or without decimal places. Both can come under without decimal places. Next, third one, we have the character constants. So here single characters are called character constants. And single characters or character constants must be enclosed within the single quotes. Okay. For example, yes, and then a. And for example, I'm writing 5 or something like this, numeric. So if you enclose that number within the single quotes, that cannot be considered as a number. It can be considered as only a character. So we cannot use it in further mathematical calculations. Whatever we enclose within the single quotes, it is only a character. It cannot be used as a numeric. So character constants. Next one, string constants. So we know that group of characters is called string. And here strings must be enclosed within the double quotes. Now say here example, say Sathesh, and say here something like monopoly, and like here 1, 2, 3. This is also a string. That is not a number. String constant only, what we enclose within the double quotes. And the second one, say here secondary constants. Secondary constants are nothing but say here arrays. We have the structures, we have the unions, we have the pointers, and so on. So let us understand these array structures and later. Now, these are the constants and primary constants and the secondary constants. Right. And what is meant by data type? What is meant by data type?
The type of variable that we are storing in, either integer or a character or a string.
Right. Let us say there are four characteristics of variables depends upon the data type. For example, if I create a variable, something like integer a, as you said, in a, what kind of data I can store? For example, as because integer, we can say that all whole numbers you can store. When you say whole numbers, I'll ask you the next question. What is the range of data I can store? So up to 1 lakh or 10 lakhs or 20 lakhs or what is it? That is the range of data. If I say in C sharp, integer occupies 4 bytes of memory. So minus 2 to the power of 31 to 2 to the power of 31 value you can store. Immediately my question is, how many number of bytes this variable will occupy in the memory? That is number of bytes it occupies. And fourth one, what are all operations we can perform on the data? For example, if you store alphabets, if you ask me to perform the mathematical operations, it is not possible, right? So, four characteristics. Simply, we can say definition of data in the memory. And the data type determines the following four characteristics. Four characteristics of a variable. So data type determines four characteristics of variable. One is like type of data stored. Type of data stored. Second one, range of data. Range of data. Third one, number of bytes it occupies. Fourth one, operations can be performed. Operations that can be performed. These are the four characteristics of a variable, depends upon the data type of that variable. See, in any programming language, we have predefined data types and we can define our user defined data types also based on the requirement. And most of them are common data types in all programming languages, and like this integer, float, double, and then character, and then string, and then boolean. These are all the common data types in all programming languages. And now, so these data types are divided into two categories. In C sharp, in Java, and in JavaScript, everywhere we have two different types of data types. One is like here value types, or we can call them as primitive types. Value types, or we can call as primitive types. Okay. In these types, in value types and primitive types, variable value will be stored in the memory. Variable value will be stored in the memory. Second one is the reference type. Reference types variable stores the address of another memory location. Here variable value will be stored. The next one is variable address will be stored in the memory. Value and address. Okay. So value type and primitive types. Here like we have the integer, we have the float, and we have the double, we have the decimal, and then say boolean, and then byte, and then say struct, and then say enum. So these are all comes under the value types. These are all comes under the value types. And one more thing. See, in all programming languages, like from C, C++, Java, C Sharp, and all the things, memory map contains two different things. Like here, first one is, we can say, stack memory. So here it is called stack memory, and here it is called heap memory. Stack memory is for the static memory allocation. Heap memory is for the dynamic memory allocation. Say, for example, if I use a variable integer a equal to 100. Okay. Next one, there is a sample class. I am creating an object equal to new sample class. So now what happens is, here for the A, it is going to allocate memory in the stack memory, because that comes under the value type. For value type, memory will be allocated in the stack memory. For all reference type, memory will be allocated in the heap memory. And even if the heap is used for the reference type, that reference will be stored in the stack. So now what happens is, here this is A, right? So A, like here, A equal to 100. Memory is allocated in the stack and that value is stored in the stack. And here, this is the obj, which is the reference variable. And this reference variable is pointing to this memory location. So this is an instance created for that sample class. And now this reference variable is pointing to this one. So first is a value type. For that, memory will be allocated in the stack. Second is a reference type. For that, memory will be allocated in the heap. So stack memory and heap memory. So for all value type variables, uses the stack allocation. All reference type variables uses the heap allocation. Stack allocation and heap allocation. So there are the two different data types and two different memory locations. So now these are all comes under the value types. Next, when it comes to the reference type, reference types, we have the class, we have the interface, and then here delegate, and then say here array, and then object, and then string. Object and string both are the built-in reference data types, and the class, interface, delegate, array are the user-defined reference data types. So these six comes under the reference data types. So these six uses the heap allocation and the primitive types uses the stack allocation. So that is about data type. I'm not giving you the size, number of bytes allocates for this int, float, double and all. So today you read all these things now, or you can see in this Copilot also here. What you can say, data types in C Sharp. You can make use of this Copilot. And so value types, integral types, floating point types, float double, decimal type, character, boolean, and reference types. Okay, na? You just go through these things. Go to this Microsoft, where you can find out all these things. Okay. And there is a keyword what we are using in the program and what is the type actually. And all these are defined in the system namespace. See, everything is nothing but a class only. For example, if you click on something like int 32, normally int we are using int 32. It is a class again. Structure it is a structure and the definition, how it will work. You can see this one. So you may not be able to understand all the things as of now. You can see the definitions and all. Remaining things we'll see later. Okay. Today you see these things and data types. Okay.
Uh,
Next. Yeah. చెప్పండి.
ఏం లేదు, జస్ట్ ఆల్ రైట్ అంటున్నాను.
Okay. So that is data types. Next thing is like, operators. Operators. What is meant by an operator?
The action that we usually perform with variables, either addition, subtraction, or
Very good. Right.
scope.
The action what we perform is called an operation. Operator means which performs the action is called an operator, and which it is performing the action is called operand. Operands and operator. Which, as you said, like plus is an operator. A plus B. Plus is an operator. A and B are called operands. Which is performing an action is called an operator, and which it is performing the action is called operands. And these operators are of basically two different types. And unary operators and binary operators. Unary operators, like, they require only one operand, like plus plus and minus minus. They require only one operand. And binary, definitely they require two. For example, plus, we need two variables to perform the arithmetic addition. And here, say arithmetic operators. There are different types of operators again. Arithmetic operators, plus, minus, multiplication, division, and one more is modulus. So we know that slash will give you the quotient, modulus will give you the remainder. So these are the arithmetic operators. And the logical operators. What are the logical operators? Logical AND operator, it is denoted with the double ampersand. Logical OR operator, denoted with the double pipeline. Logical NOT operator with an exclamatory mark. So when you are performing more than, or when you are checking more than one condition, we use this logical operators, AND operator or OR operator. And NOT operator will give you the reverse. For example, status equal to true. What I want to do is, when the status is true, I want to make it false. When it is false, I want to make it true. How can you write code for that? If the status is true, I want to make it false. If the status is false, I want to make it true. So what you
We'll
can
use
do?
a if else statement.
Pardon?
Oh, I was just saying we'll use if else statement using the not operator.
So we can write like the status equal to true, then status equal to false we can write. Else case, we can use that status equal to true. Status equal to true. So we can write like this. Or instead of writing like this, what you can do simply status equal to not status. That's all. If you write status equal to not status, if it is a true, it will give you false. If it is false, it will give you true. We can write like this. So two not operator will help us. And AND operator. AND operator means if all the conditions are true, result is true. OR operator, if any one condition is true, result is true. That is the difference. Next one, assignment operator. What is the assignment operator? Equal to. Remember, when you are using an assignment operator, always left side should be a variable. So variable equal to, it can be a constant right side, or it can be a variable, or it can be a expression. A equal to 10, variable equal to constant, or A equal to B, variable equal to variable, or A equal to B plus C, variable equal to expression. But left side should be always variable. It cannot be a constant, it cannot be an expression. Next one, relational operators. What are the relational operators? we have that less than or equal to, greater than or equal to, double equal to, and not equal to. Double equal to for the equality condition, not equal to for the inequality condition. When you want to check, when you want to compare equality, double equal to. When you want to compare inequality, not equal to. And you know this less than, greater than, and all these things. Next one, arithmetic assignment operators. Arithmetic assignment operators. So like we have the plus equal to, minus equal to, star equal to, slash equal to. So here we have both arithmetic operation as well as assignment operation. For example, if I write a plus equal to b, that means uh, a equal to a plus b. So this is only a simplified form only. There is no advantage or disadvantage. Instead of writing a equal to a plus b, simply you can write that a plus equal to b. It makes no difference. However you want, you can write it. Okay. In the same way, like a minus equal to b. So here a equal to a minus b. And third one, say here a star equal to b. That means a equal to a into b. And fourth one, like a slash equal to b. That means a equal to a slash b. These are the four arithmetic assignment operators. Okay. Okay, and tomorrow we'll continue this one. I'll do one thing. I'll save this file and I'll send you in the group. Once again, all of you go through this, what you can say, uh, .NET framework architecture in the internet and read about the framework architecture, all of you.
Okay.
Sir, I just have a small question.
Yeah,
Earlier, you were saying that it supports structure, enum, and pointers too, right?
yeah,
But and morning you told that C sharp is object-oriented programming.
yeah.
But supporting pointers and structures, will that make it not OOPS concepts?
No, it's OOPS concepts only. It comes under the value type. When you create a structure, it allocates memory in the stack.
Okay. Because usually while learning Java, they usually say Java is object-oriented programming, so it doesn't support pointers and structures.
See, even Java also uses the pointers concept. But
Ah,
as
yes,
far
sir,
as
but in a different way. Yeah.
Java, what happens is like, as far as concerned, our programming context, pointers concept is not available. See,
Yes.
normally the main usage of the pointers. So generally, what is the use of pointers as per your knowledge?
Um, we usually store the address of the variable instead of directly storing the
What is the
variable.
advantage of using storing a address? See, if I teach C, even I also will tell that pointer is used to store the address of a variable.
Yes, sir.
But generally, if your program wants to interact with any of the physical device in the system, let us say if my program wants to interact with the keyboard, if my program wants to interact with the mouse, if my program wants to interact with the memory device, then we should make use of the pointers.
Okay.
That is the reason ఇప్పుడు మీరు డైనమిక్ మెమరీ అలొకేషన్ చేస్తున్నారు కదా, MLOC,
Um,
CLOC and all this. There we are
yes, sir.
using the pointers only to interact with the memory.
Okay.
So even in the Java also, if you want to allocate memory in the runtime, there should be a pointers concept internally. JRE uses the pointers concept to allocate memory. But as far as our programming context, there is no pointers concept.
Concept. Yes, sir.
In the C sharp, even in the programming context also, we have the pointers concept. But if you make use of the pointers in the programming, we call it as a unsafe programming.
Okay, sir.
Because
Yeah.
if you have the pointers concept, or if you use the pointers concept, with the help of that, you can interact with any of the memory location. You will be able to change the things.
Things.
That is why it is called as a unsafe programming. So to overcome that problem in .NET, we have a class called memory stream.
Okay, sir.
So with the help of the, normally when you are working with the images and all, it will come and
Okay,
image
sir.
processing projects అవి చేసేటప్పుడు ఈ మెమరీ స్ట్రీమ్ క్లాసెస్ యూజ్ చేస్తారు జనరల్, ఆర్ ఎల్స్ వీఆర్ సపోజ్ టు యూజ్ ది పాయింటర్స్. సో ఇన్స్టెడ్ ఆఫ్ యూజింగ్ పాయింటర్స్ దే యూజ్ ది మెమరీ స్ట్రీమ్.
Okay, sir. Thank you, sir.
ఓకేనండి, టుమారో విల్ మీట్ అగైన్. సో ఆల్ ఆఫ్ యూ కెన్ అండర్స్టాండ్ తెలుగు, రైట్?
యా అందరికీ
Ah,
వచ్చు మామూలు.
ఓకే ఓకే ఫైన్. సో ఈ రోజు ఒకసారి ఇవి ఆల్ ఆఫ్ యూ గో త్రూ దీస్ కాన్సెప్ట్స్ ఇన్ ది ఇంటర్నెట్ అండ్ .NET ఫ్రేమ్వర్క్ ఆర్కిటెక్చర్ అండ్ బేసిక్ థింగ్స్.
ఓకే
ఫైన్ ఫైన్.
okay, sir. Thank you, sir.
థ్యాంక్ యూ.